Welcome to the lecture. In this lecture, we are going to discuss about the addressing modes of 8051. So there are different addressing modes in 8051 microcontrollers. In 8051, there are 1 byte, 2 byte and 3 byte instructions which we have discussed earlier. The opcodes are 8-bit long. As the opcodes are 8-bit data, there are 256 possibilities, right? So among 256, 255 opcodes are implemented. The clock frequency is 12 Hz and 64 instruction types are executed in just 1 microsecond and rest are just 2 microseconds. So the multiplication and division operations takes up to 4 microseconds to execute. So let us discuss the basic 6 types of addressing modes of 8051. So first one is immediate addressing mode, second one is register addressing mode, direct addressing mode, register indirect addressing mode, indexed addressing mode and implied addressing mode. As we have seen, few of addressing modes are similar to the 8085 as immediate, direct and indirect. We have discussed these addressing modes in 8085 itself, right? So let us discuss deeply of these types. So first one is immediate addressing mode. In this addressing mode, the data is provided in the instruction itself. The data is provided immediately after the opcode. So you can see here move A, whereas move A is an opcode and 0AFH is an operand, whereas move R3 is opcode, 45H is an operand. So these are some examples. Let us see here. In these instructions, the symbol is used for the immediate data. In the last instruction, there is a DPTR. The DPTR stands for the data pointer. Using this DPTR stands for the data pointer. Using this, it points the external data memory location. The first instruction immediate is AFH, but 0 is added at the beginning. Why the 0 is added? So when the data is starting with the 0, the data should be preceded by 0. So should be preceded. If starting bit is 0, it should be preceded by the other numbers. Next one is register addressing mode. In this addressing mode, the source or the destination should be present in the register format, that is R0 to R7. These are some examples of register addressing modes. Like you can see here, move A, R5, where R5 is the register mode. Move R2, 45. Here the destination is R2. Where R5, in the first instruction, we can see R5 is the source where it is mentioned in the register format. So in 8051, there is no instruction like move R5, R7. So there is no instruction where both one are registered. We can get the same result by this using the instruction like this, or by using in the move 05H or R7. But this two instruction will work only when the selector register bank is RB0. To use another register bank to get the same effect, we can add starting address of the register bank with the register number. So we have to add the starting register number. For example, RP2 is selector. We want to access R5, then the address should be 10H plus 0H is equal to 15H. Right? So the instruction will look like move 15H, R7, where 10H is the starting address of the register bank 2. And next one is direct addressing mode. In direct addressing mode, the source or the destination is specified by using 8-bit data in the instruction. Only the internal data memory can be used in this mode. Here some of the examples like move 80H, RC, where directly the data is specified. The source or the destination specified by using 8-bit data. You can see here 80H is a 8-bit data, 45H is the 8-bit data. So the first instruction will send the content of the register R6 to the port P, that is address of the port P is, if the address of the port P is 80H, then it will share the content of R6 to the port 0 of the 80H. The second one is for getting content from, that is getting the content from 45H to R2. and the third one is used to get the data from the register R5 to the register R5. So in the next lecture we will discuss the other T types.